This is a little piece of our section on graphs that I like to call What's Wrong with This Chart? And what we're going to do is we're going to look at a few graphs and charts that are incorrect in some way and look at what might have happened and what we should avoid or watch out for whenever we look at data. So on this first one, you've probably already noticed that these numbers do not add up the way they should. And instead of just laughing at it and moving on, I want you to think about what might have happened for them to have made, in case you haven't caught it, all these numbers add up to 70 and 60s, 130%, and then we have another 63 on top of that. I want you to think about what might have happened. Now, hopefully you might have paused and considered it. My idea of what happened is that this was originally asked in a series of 3 different questions. Do you back Palin? Do you back Romney? Do you back Huckabee? And those were asked as yes or no questions, as opposed to a question on which of the 3 candidates do you prefer. So the mistake here isn't so much that the percentages don't add up, it's that they're using the wrong chart entirely. You don't want to use a pie chart for something like this. If that is what happened, and if this is how the questions were asked, then it might be better to use a bar chart to have a basis of comparison between the 3 figures. Now, I had mentioned the area principle last time, but I want to go through it again because I think it's something that is easy to do wrong, especially on pie charts. And so you want to make sure that your area is taking up the correct slice to the actual amount of area that it should take up. If something is 20% of the data, then it should take up 20% of the picture. So this is an example. This 3D image right here is creating this entire slice that's here on my blue that isn't there on the green. And that's inflating the slices of the pie that are closer to you than the ones that are farther away. In fact, if we go back, you'll see it here too. Notice how the 60% looks like a much bigger slice of the pie than the 70% does. That's what a forced perspective can do. So make sure your pie charts are in 2 dimensions. Make sure you're keeping an eye on your areas and make sure they're taking up the correct amount of area. Here's another example. This is actually out of our book. So again, pause and see if you can spot what's off about this chart. Hopefully what you noticed is the labels down here. Because they go into 2-year sections. This is combined 91 and 92. This is combined 93 and 94. This is combined 95 and 96. And then all of a sudden, only 97, only 98, only 99. When really, this should combine 97 and 98 and stack the bar on top of each other. And one thing I want you to think about as you're looking at this is, why are we interested in this data on airline passengers, and what conclusion might a misleading chart like this lead us to make? And this is why we need to be careful when we're making and looking at graphs and visualizations of data. The last example here is a more recent one. So again, pause and see if you can spot what's wrong. Okay, just so you know, this is actual data put out by the state of Georgia. And what we want to think about again is, what conclusions might it lead us to that are wrong or misleading? And the thing that it might be hard to notice from this chart is that there was a spike in these 2 weeks. And the reason the spike is hidden is because the legend has changed. The number of cases they're assigning colors to is different in the second chart than it was in the first chart. As a result, it makes it look like the cases haven't gone up all that much, when in reality they have. And hopefully this all lets you look a little bit closer at the data that you're looking at and doesn't let a nice looking visual mislead you. And here is your second homework assignment to get started on. That's all for today.